All right, so here's our precalculus problem of the day. So this one, we have sketched a graph of a function where it's a piecewise function, f of x equals 2 when x is less than or equal to -1, and then f of x equals x squared when x is greater than -1. So really, this is fairly simple if you know your basic graphs, generally speaking. So you know what a quadratic looks like, you know what a constant function looks like, or a linear function, or all the basic types of functions that you've probably run across. Um, it's basically just graphing part of that, graphing part of another one, and then seeing where they split. So the first thing I like to do if I'm having to sketch one of these piecewise functions is we see where it's split, and this one's split in one place into two pieces. It could be split in two places, and then it'd be in three pieces. Same idea would work. We see this one is split at -1. So what I like to do is kind of draw a dotted line coming down through -1 like that. And now when we're on this side over here, we're going to have f of x equal to 2. When we're on this side over here, we're going to have f of x equals x squared. And so if you know what those functions look like, you could go ahead and graph it. If not, one thing you can usually do if you have to graph something by hand is to create a table. And so let's do that over here. So I have fx and f of x. And this will generally always works. It'll always work. A lot of times, well, sometimes maybe it's not worth it, but most of the time, probably it is. And maybe not worth it is not maybe the right phrase. Um, it may not be exactly possible, but probably for any graph that you're going to see in pre-calculus, especially if you're asked to graph it, likely it is possible. And when you get to calculus, you learn other techniques for doing this, but a very easy way to see what a graph looks like is to create a table and plot points. So now notice this is not uh, unintentional. I put -1 on there twice because that's where this is split. Now, the function is not um, valid at both of these pieces. It can only be valid at one of the piece. And that goes back to the vertical line test. If you had 2 points at x equals -1, so you had a point there, maybe and a point there, then it would no longer be a function because you cannot have one input giving two outputs. Each input can only give one output. That's the definition of a function. But we do need to, because for x less than or equal to -1, on coming from the left, the graph is going to go all the way up to that point, or this imaginary border. On the right, it's going to go all the way to it without touching it, but there's no distinguishing. If you're coming this way, you're going to get all the way, as far as we can tell with our naked eye, you're going to get all the way to that, but you don't actually touch it. But as far as we're concerned, there's no horizontal gap between the x equals 2 up here, and then when you get past -1, you go to x squared. There's no visible gap there. I guess there is an actual gap, um, kind of, but the reason we're doing that is because we do need this x squared to go all the way as close to the -1 as we can get. So up here above this dotted line, we're going to use f of x equals -2. And then down here, we're going to use f of x, or sorry, +2. And then over here, down here, we're going to use f of x equals x squared. So if f of x is 2, it doesn't matter what your x is, you're always going to be at 2. And then now when x is -1 and beyond, we're going to plug this into negative to x squared. So -1 squared is 1, 0 squared is 0. 1 squared is 1, 2 squared is 4, 3 squared is 9. And so we'll add another one. We won't actually do the 3. We'll add one there. So let's plot -3, 2. So that would be right there. Negative 2, 2, negative 1, 2. Now, here's where you need to pay attention to where is the equal part of this piecewise function. So if it has the equal part, we're going to use a closed circle to denote that point. If it doesn't have the equal part, we're going to use an open circle. So since the x equals negative 1 is actually included in this part, so it's included there, it's actually not included there. Um, since it's included here, we will put the closed circle. And so now we can connect this, and it's going to continue to go in that direction. Just horizontal line through the y equals 2, and that gives us the left side of this, the left piece of this function. Now we're going to go to the x squared part, and it's still just plotting points, but we have the closed circle here, we have the open circle there. So when we plot negative 1, 1, we need to use open circle there, because that point is not actually there. That point is actually here. So very important distinction there. Then we have 0, 0, we have 1, 1, and 2, 4. And if you want to keep going, you can go up to 3, 9, but we're not going to draw it up that high. Then just connect these, and you should know what a quadratic looks like. It's got the U shape. I didn't actually go through my points, but there we go. Okay, so that's what that looks like. The important parts of these graphing piecewise functions, make sure that uh, you pay attention to where it's split. So this dotted line is not actually part of the graph. It's more of a guideline. And you could erase that on your paper if you were drawing this. And then the other part that you want to make sure you pay attention to is where the open circle is, open circle or closed circle. Um, and yeah, so know your basic graphs, and then pay attention to those couple of things when you're doing a piecewise function, and you should be good. So not too big of a deal there. All right, if you have any others you want me to do, you can drop them in the comments or send me an email.